Hello everybody, this is Mr. Bowman. Today we're going to be looking at the topic completing proofs involving congruent triangles using SSS or side, and side, angle, side, or SAS. So we have some given information here. We're going to prove that these two triangles are congruent. So we have PQR over here and TSR over on this side. So let's start by just marking the parts we know. We know that QR is congruent to SR. That's our first given here. So QR is congruent to SR, so those are both the same size. And we know that PR is congruent to TR. So we have PR here, it should be congruent to TR, but not necessarily congruent to PR, so we're going to use a different number of hash marks to mark that. And that's it. That's all the givens we know. So remember, we're going to start off by listing out our givens. So we're going to bring these down here to our first couple steps. So QR is congruent to SR. The reasoning, remember, as soon as it's one of our givens, that's actually the reason we put down here. And then here it actually tells us the next one's a given, which we can probably guess here because that's all we have so far. We just have to fill in the second half. So we know PR is congruent to something, so we look up here. PR is congruent to TR. And it's usually safest just list those in the same order. So just do the exact same order they had when you wrote it out here. Okay, and that's it for our givens. So now I have two congruent statements, right? I have line 1 and line 2. I need a third one in order to prove triangle congruence using either SSS or SAS, and that's why there are 3 letters. Remember, those are the congruent statements I'm looking for. So either 3 sides, so we have a side here and a side here, or 2 sides and an angle, and the angle has to be between those 2 sides. So I'm trying to figure out this last one, and it says PRQ is congruent to TRS. So let's look at where that fits in. So we have PRQ here and TRS. So we're trying to say that this is congruent to this one. Now, why is that the case? So remember, this is our bow tie shape. It's one of the 2 most common ones. The other one is where we have maybe a triangle like this, where we have a shared side. So we have kind of this left side and this right side. That's where we have that shared side and have the reflexive property. This bow tie is the second one we looked at. So these are on opposite sides of that single intersection R. So that actually is our vertical angles property, because that's what they are, right? So if they're on opposite sides of an intersection like that, they are vertical angles. So the vertical angles property says if you have 2 vertical angles, then they're congruent. So that's why I know they're congruent. Okay. So now I have my 3 congruent statements. I have line 1, line 2, and line 3 here. And I just have to figure out which property am I using. So let's look at what I have. If I just look at one of the triangles here, I have 2 sides and an angle. Okay. So knowing that these are our only options, it has to be SAS, so 2 sides and an angle. But we don't always know that, so let's just talk through that reasoning really quickly. The reason I know it's SAS is looking at the 2 sides is the angle in between the 2 sides in our picture, just like the A is between the 2 S's here. So if I look at that arc that I drew there, is it touching the 2 sides? And the answer is yes, it's touching the 2 that I know are congruent. If I had, say, this one over here, it wouldn't be touching this side here. Oh, I'm sorry. If I have this one here, it wouldn't be touching that side over there. So that would not be SAS. So in order for it to be SAS, that angle has to be touching both sides. So I'll just put down SAS congruence property, and we are good to go.